All right, hi everybody. So we previously took a look at how we could find the inverse of this matrix over here, this 3 by 3 matrix A, we'll call, which is top row 0, 1, minus 2, and the second row 1, 0, 0, and the third row was 0, 0, 5. And we were able to find the inverse of this matrix A by identifying that it was a result of 3 elementary row operations applied in a certain order. And if we invert each of those operations and then take them in the reverse order, we can wind up with finding the inverse of matrix A. In general, looking at a matrix A, it may not be evident what elementary row operations were used to generate it, or there may be a ton of them that we need to keep track of. So here's a nice algorithm for keeping track of which operations were required to generate matrix A. So I'm going to set up an augmented matrix where I have my given matrix A, which was 3 by 3, and I'm going to augment it with an entire 3 by 3 identity matrix on the right. And I just have this red dashed line over here separating what was the matrix that we started with what is the inverse. And we're going to try and row reduce this entire matrix put it into reduced row echelon form. And so in doing so, by trying to put A into reduced row echelon form, what we're going to be doing is exactly applying the opposite, the inverse elementary operations in the reverse order. So let's take a look at what we could do. So here, for example, if I want to write this in reduced row echelon form, one operation that I can do is scale the last row by a factor of 1/5 so that this pivot down here becomes 1. And I will just mention that this row reduction process, it's not a unique path, right? We can apply different operations in different orders to wind up at reduced row echelon form. So you may think about a different sequence of operations that you could apply. But what we're going to do here is basically scale row 3 by 1/5. And this is what we called E3 inverse on the previous slide. So we kind of first are going to apply E3 inverse to both of these matrices. And that scales this by 1/5, and that's where this 1/5 comes from. Then we can think about what's the next operation. So again, my goal is to take this matrix and put it in reduced row echelon form. So let's do a little interchange of rows so that this first pivot is in the top row. And so after doing that operation, we now have flipped rows 1 and row 2. And here is what state the original matrix A is in terms of getting it into reduced row echelon form. And here's the kind of state of what's going on as we're generating the inverse. So far, what is on the right of this line, what we're keeping track of for the inverse, we've obtained by taking E3 inverse and then multiplied E2 inverse, and that puts us here. And now, lastly, what we can do is multiply, we'll do a replacement on row 2. We're going to replace row 2 with 2 times row 3 plus row 2. That's going to undo this over here. And after this third operation, which I should note is what we called E1 inverse, on one of our earlier examples, we now have undone all of the operations that matrix A has done. So matrix A is now in reduced row echelon form. And what we have over here is the product of E3 inverse, E2 inverse, E1 inverse, which is exactly giving us the inverse matrix for A. So this matrix over here is equal to A inverse. And that we found by first taking E3 inverse, then E2 inverse, and then very lastly E1 inverse. So this is consistent with the work that we did in one of the earlier videos, but now this gives us a nice algorithm for how we can keep track of all of these different elementary operations that we're applying. And you would want to check at this point that this matrix over here, A inverse, when you multiply it by the matrix A we started with, both on the left and on the right, they give us the identity matrix back. So after doing this operation, these elementary row operations on this augmented matrix, if we're able to get the identity, if we're able to reduce A to the identity matrix, then by doing those same operations on what started as the identity matrix, we wind up with A inverse on the other side. So the additional stuff that we added on, applying those operations to that additional stuff helps us track down what A inverse is. We've seen plenty of situations where we have a matrix A, and when we write it in its reduced row echelon form, we don't have a pivot in every single column. So if we're going through this process and we hit a dead end, and we see that the reduced row echelon form of A is not the identity matrix, then what that tells us is that A does not have an inverse. A is a singular matrix.